Hey there, friends. It's Ellen Weatherford.
And Christian Weatherford.
And this is Just the Zoo of Us, your favorite animal review podcast, where we take your favorite animals and rate them out of 10 in the categories of effectiveness, ingenuity, and aesthetics.
We are not zoological experts, but we try our best to bring the most accurate and relevant information that we can.
And I have managed to tear myself away from Zelda for long enough for us to record this episode. Please clap. I mean...
As well as long-distance house hunting.
Yes. We've got a lot on our plate right now, but let's take a brief break from all that to talk about animals.
Yes, please.
Please, anything but that. Literally anything else that I could think about.
I sure hope you don't have a house fly or something.
No.
House.
A welcome distraction. Although it rhymes with house.
Louse.
Nope, not that.
All right, what you got?
Grasshopper mouse. There are 3 species of grasshopper mice. They belong to the genus Onychomus, I think is how I'm going to say it. Onychomus, maybe?
I like the first one better.
These creatures were submitted to us via email by Jeffrey Butchart. Thank you, Jeffrey.
Yes, thank you.
I'm getting my information from National Geographic, Animal Diversity Web, the Arizona Sonora Desert Museum, and articles that will be cited along the way because they contain spoilers in their titles.
Per usual.
Yes, so to get right into it, for the grasshopper mouse, let me introduce you to our tiny friend.
Mm-hmm.
Their adult size is only 3 to 5 inches long as they are a little rodent guy.
Does that include tail length?
That does not include tail length, but here's the weird thing about the tail. The tail is like a weird, like awkward medium length is how I would describe it.
Oh.
Like it's longer than a hamster's, but it's shorter than a mouse.
Got the middle slider effect.
It's weird. Like you don't normally see them in this weird, awkward sort of middle stage of like mouse tail length. It's really weird. And they are found in Western North America. They can be found in deserts and arid grasslands, scrubs, things like that. Mostly in the sort of Southwest, but they can also be found in these like drier grasslands all the way up into like Canada.
Okay.
So, despite their resemblance to the common mouse, which has the scientific name musculus, they are more closely related to hamsters, lemmings, and muskrats. So, there's actually a whole entire group of rodents that are called New World rats and mice.
Okay, this
that
naming.
look, yes, this again. They look identical to the rats and mice that we might be thinking of, more like European rats and mice.
Okay.
But they're not related. Like they're more closely related to like hamsters and lemmings and stuff.
Okay.
Which is really interesting to me that they're not as closely related as you'd think they would be based on their appearance.
Is this yet again convergent evolution?
I mean, I guess you would call it that, or it might just be that they all came from a common ancestor that more closely resembled a rat or a mouse, right? And maybe they just retained those traits.
Okay.
So I don't know enough about rodent evolution to tell you which way that went. If you're familiar with the episodes we've done in the past where we talk about these like particularly southwestern desert animals, there's some weird stuff going on out there. The deserts are not okay. Like the animals out there are so weird.
Just watch Rango and you'll get an idea.
Yeah, if you've seen Rango, yeah, you know the vibe.
Save for the chameleon, I suppose.
Yeah, that's a little bit of a wild card. But even in the movie, he's clearly like he
out of
fell
his
out
element.
Yeah, he's not where he belongs.
It's the whole driving conflict.
Yeah.
Anyway, enough about Disney's Rango.
Was that a Disney movie? Was it? I don't think it was.
Maybe it was Dream.
You can get there. You
not
know this.
Dream Star, not Dreamcast.
Where are you going?
The Shrek DreamWorks.
There
it
you
is.
go. Oh, you did it. You made it home. I'm so proud of you. But yes, we're not talking about that at all. So to get into our ratings for the grasshopper mouse, for effectiveness, which is physical adaptations, things that are built into the animal's body that let it thrive and survive, I'm giving them a full 10 out of 10.
Wow.
For a very surprising reason. So this little tiny rodent challenges every stereotype you may have in your brain about rodents. So like whatever you know about rodents, you can just kind of like crumple it up and throw it in the trash because this is an absolutely bizarre rodent. First of all, this is like if you took a mouse from like a Fallout irradiated wasteland. This is like a Mad Max sort of like post-apocalyptic mouse. First of all, this mouse is a voracious predator.
Okay.
Like lethal, bloodthirsty predator.
Oh, okay. So Okay. I was like, maybe they're friends with grasshoppers?
No, not at all. Well, so a lot of rodents and a lot of mice will be kind of like opportunistic omnivores, where like they might eat like a bug here and there.
Sure.
But this mouse is up to 90% prey animals. And this is not limited to bugs. They will eat vertebrates as long as they are small enough for them to take down. So not necessarily their size. They will take down prey larger than themselves.
Uh-huh.
So this could be snakes. This could be other rodents. Like, anything that they could feasibly kill, they will kill and eat. Literally anything at a moment's notice.
What a confusing moment for a snake.
Call an ambulance, but not for me.
Just play the Uno reverse on that snake.
Yeah, basically. There were even studies where in captivity, they prefer live prey to either pellets or prey that's already dead. So like when fed things like crickets, they would prefer to hunt and kill and eat the live crickets than just eat the crickets that were offered to them already dead. Implying that they have this like prey drive. You know, a lot of predatory animals will only eat prey if they can also like hunt it first to kind of avoid like maybe it's sick, maybe it had a disease or something wrong with it. You don't want to like eat prey that was already killed by something else because you don't want to like run the risk of getting a disease from it. These mice like have a prey drive.
Yeah. I wonder if there's anything in there about like wanting to avoid the other animals that will scavenge dead creatures like vultures and things.
It doesn't seem like these mice particularly care about avoiding conflict. It doesn't seem like that's something they want to do.
That's fair.
It seems more like they actively seek it out.
Dear desert, I wish you would.
They're absolutely bloodlusted. So they hunt and eat anything that's small enough for them to take down in the American deserts where they live. That often means going toe-to-toe with some particularly heavy hitters. We're talking giant centipedes, extremely venomous scorpions, tarantulas, stuff like that, like arthropods that are built in with like insane defenses, right?
Yeah. Including
a particularly well-known one, the bark scorpion. Bark scorpions are the most venomous scorpion in North America. They're known for having a sting that causes this like searing, agonizing pain that lasts for hours. This scorpion has caused at least 3 known human fatalities since 2000. And it's thought that the potency of the scorpion's venom could possibly be the result of an evolutionary arms race with this mouse. Because the mouse hunts and eats the scorpion. So the scorpion is developing a stronger and stronger and stronger venom to try to fend off the mouse. So when your dinner menu includes extra spicy options, you have to do what a lot of adventurous eaters have to do and develop a tolerance to spice, right? So grasshopper mice they're immune to a lot of different types of venom. Venom that's produced by the arthropods that they eat, but also by things like snakes. They have a lot of venom immunities built in. That's pretty common. For things that eat toxic things, that's pretty common. But they take it a step further than just immunity, particularly when it comes to the bark scorpion. I'm going to give you an extremely simplified summary of a neurological concept.
Yeah.
Because I don't have a background in neurology, so I don't understand a lot of this stuff, but I did a lot of reading about this, so I'm going to try to give you what I understand of it. In mammals, pain signals are felt when 2 sodium channels...
I knew it.
I can see your face drop. You're like, no.
Here's coming the sodium.
Not sodium channels. All my homies hate sodium channels. So 2 sodium channels, which by the way, act kind of like a door into the cell to let sodium in or out, I suppose. When 2 sodium channels in nerve cells are activated, it's these 2 very specific ones. They open the doors to the cell and they let sodium ions through the door into the cell. So when both of those doors are open, letting sodium in, that's when the neuron signals pain. That's when you feel pain. In grasshopper mice, one of those 2 sodium channels, so one of them initiates the pain signal and the other one propagates the pain signal. The channel that propagates the pain signal, so like sends it through to the rest of the nervous system and like sends the pain signal through your body. That sodium channel is shaped in a really unique way, such that when the venom like molecules try to activate it, which they do kind of like almost like a battering ram, they kind of like force their way through the door and force the sodium channel open to let the ions through and like force the neuron to feel pain. But when this particular venom molecule tries to activate that sodium channel, it instead binds to it and gets stuck, kind of like a trapping lock. So on our mailboxes, on our cluster mailboxes, we have for like a parcel box, if you get a package, you'll get a key in your mailbox, you use that key on the parcel box, and when you unlock the door, it sticks and you cannot get that key back out.
Right.
Intentionally. It's supposed to stick in there so that then the post office can use that key for the next lock.
Yeah.
So it's kind of like that, where the sodium channel binds to the venom molecule, and the venom molecule kind of blocks it and prevents that channel from opening at all to anything, not just to the venom. So what this means is that it blocks all pain signals. So they have turned the venom into a painkiller. So they actually go numb and they don't feel any pain when they're stung by this scorpion.
Yet another Uno reverse.
They're playing every reverse card in their deck. So basically, like, the pain button is blocked. You cannot press the pain button. So you can watch videos of this mouse fighting with this scorpion, where the scorpion will sting the mouse, and for a second the mouse will be really bothered by it, and it'll kind of like, you know, rub its face or lick its paws or wherever it got stung. It'll sort of like, it'll experience pain for like a few seconds, and then the venom activates and it kills the pain. And then the mouse just like turns around and just goes all out on the scorpion. And it's just like getting stung and stung and stung over and over again. The mouse doesn't care. And then the mouse will really like go on this all out attack, because it's basically been like, it is as if the scorpion was just stabbing the mouse with a syringe full of ibuprofen.
Second wind.
Yes. So, you know, it's really interesting because the scorpion is trying to like inject more venom in it and making the mouse stronger. It is a very interesting way to like not only negate the effect, but use the effect to its own advantage. So there have been like a lot of studies where they study like grasshopper mice hunting these bark scorpions, where they would also cause pain to the mouse after it had been injected with the bark scorpion venom, and it was unbothered by it. Like, less bothered after receiving the scorpion venom than it had been otherwise.
But this isn't causing, like, muscle paralysis or anything like that.
No, it is just a pain signal that the mouse is completely unfazed by. So, you know, part of the paper that I read about this explained that is actually like a really high pain tolerance, or like having the ability to like ignore pain or not feel pain is actually really, really dangerous in predators, because then you might be ignoring something that's going to kill you.
Right. That's the whole purpose, right?
Pain is supposed to be like letting your body know something's wrong.
Like some damage is happening.
Yes. Like, hey, something is bad. Please go away. Do not be in this situation anymore.
Whatever caused that, don't do it.
So it has to be this sort of short-term thing that's only triggered by this very specific venom molecule. And it's like a short-term thing, right? It's not like they just don't feel pain ever. It's like a short-lasting sort of, you will just not feel pain during this situation because you know you could take it, basically. And this is also something that's being used now. Also in this paper I was reading about it, they were talking about how this has potential applications for like studying painkillers that can be used in humans, right? Like, we could study how the grasshopper mouse's pain receptors, how that could be something we could maybe use for painkillers in humans. I couldn't find any like more recent research on how that is actively being applied, but it was definitely suggested as like, hey, let's look at this. It
sounds like it would be a good for maybe short-term and very localized pain management.
Yeah, like a local anesthetic or something. Yeah, unfortunately, I don't understand the neurology of it well enough to go into too much detail about it. But if you do understand neurology and you want to learn more about this whole system, the paper that I learned all this from is called Voltage-Gated Sodium Channel in Grasshopper Mice Defends Against Bark Scorpion Toxin. That was by Rowe et al. In Science in October of 2013.
Cool.
Yeah. So if you know brain stuff, go check that paper out. Because I was fighting for my life reading this paper.
I forget what it was, but I remember coming across sodium channels and how it relates to venom before.
Yeah. The one other thing I wanted to include in effectiveness, because this is something I always think about when we talk about desert animals, is that when you live in this really hostile, hot, arid climate, everything needs water. All sort of living creatures need water in some capacity. That doesn't necessarily mean you need to drink liquid water, but you've got to get water from somewhere. So desert animals tend to have interesting adaptations that let them either get water from unconventional sources or just retain the water that they have and use it very efficiently. So we've talked about kangaroo rats in the past, little critters that basically have like extremely hyper efficient like kidneys and stuff that can like concentrate their urine so that they're not like passing a lot of water out of their body. And grasshopper mice don't really have that. Like they kind of do, but not as much. So they're not holding on to water as much as things like kangaroo rats are. But this like hyper predatory lifestyle is thought to be how they're getting their water.
Blood, yeah.
From blood, literally from blood. Yes. So like they can't get their own water, so they have to just basically steal it from their prey, right? Like I'll just crack them open and get the moisture from inside their body.
Yeah.
So it's brutal, but like for a very interesting reason, you know. Like that's how they gotta get their moisture somehow.
I mean, it works just like I guess the calorie channels, right? Where they're preying upon other things to take the calories that they have accumulated through their own foods, right?
Right. You let your prey do all the work finding and holding on to the water. And then arthropods and little small vertebrates and stuff like that, they basically become tiny little water balloons that are just crawling around on the desert floor. If you find one, you could pop it. There you go. Free water.
Perfect.
So moving on to ingenuity, our next category that we rate animals on, which is just behavioral adaptations, interesting things they do with their body to solve the problems that they face. I'm giving the grasshopper mouse an 8 out of 10. The best way I can describe what's going on with this mouse is that they are running Lion software on mouse hardware. Like, their behavior is what you would expect from a large carnivore, right? Like, they have very, like, big cat sort of behavior. So, first of all, they quietly stalk their prey, which is very much not typical mouse behavior if you're used to, like, mice and small rodents. Like, quietly stalking isn't really their deal. They're mostly scurrying and panicking.
Sure.
So they quietly stalk their prey and then they like pounce on it once they're within striking range. In videos that I've watched of them fighting with things like centipedes or scorpions, they do something really interesting. When they're fighting, they close their eyes and they hold their eyes shut really, really tight and then kind of fight with their like front paws and their teeth. In the videos that I saw, they pointed their ears forward. So it seemed like they were completely shutting off their eyes because they didn't want their eyes to get stung.
Right.
But then they were using their ears to like guide them through the fight and listening to the prey like scurrying on the ground and stuff.
Do they have long whiskers?
Yeah. I'd say so.
That would come into play too.
It reminds me of Toph, the earthbender from Avatar, The Last Airbender, like how she would fight like using sound and vibrations and stuff. It reminded me a lot of her.
That's cool.
Yeah, it was a cool... there are a lot of videos of them fighting stuff on YouTube. I highly recommend it. It's very interesting. You kind of have to watch slow motion videos because all this is very like happening very quickly.
Oh yeah, very anime. Like I can barely keep up with their movements. They're so fast.
Yeah, and it lasts for like 8 episodes. They also have no chill whatsoever in the sense that they bring the exact same energy as if they were hunting a fatally lethal scorpion to hunting like a cricket or a worm. Like the exact same level of hype to both fights. They're completely guns blazing in either situation.
They got to keep that knife sharp.
Yeah, basically. Because like they don't know until they're in that like situation whether what they're fighting is like venomous or not. So they're like, I'm just going to err on the side of caution and go in screaming.
Yeah.
They are ruthless, so when they hunt, they also tend to go straight for the back of the head. They will try to like sever the nerve in the back of the head and try to like take out prey early. But when they're attacking prey with defenses like stingers or things like that, they will actually prioritize disarming the opponent before trying to like, kill it. Like if they're fighting a scorpion, they'll go for the tail and they'll try to like rip the stinger off before trying to actually kill the scorpion. So I guess that implies to me that they understand where the risk is.
Yeah.
Right? Like they know like what the dangerous part is, so they have to go for that first. This is all like things that you would think to see from like a lion hunting, right? Like they would, go for the back of the neck, stalk their prey, like.
Yeah, I was thinking of the jaguar when you mentioned the back of the head thing, because that's something they do as well.
But there's another thing that they do that reminds me a lot of lions in particular that I think is something they're probably maybe most well known for. So like many other predators, they're very territorial. They do not like other grasshopper mice being near them, and they will stake their claim to their territory by standing up on two legs, throwing their head back, pointing their nose up at the sky, and howling with a pure, high-pitched tone, exactly like a wolf would, right? Like this long, drawn-out, pure tone. To us, it sounds like a whistle. Like, it's so high-pitched that it sounds like a whistle. This reminds me of lions because of how lions will do this sort of like they'll roar, right? And you can hear it for just miles around. And it's just this very sort of like territorial, like this is my range, don't come near me sort of thing. It sounds more like a whistle to us, but it looks like a scream. Like it looks like they're just throwing their head back and screaming at the top of their lungs.
It's funny.
It is adorable. There are very dramatic videos of them doing this. And it's usually like edited into like memes and stuff like that, or like they'll edit like a meme sound or something. Like very funny videos about that. But this has also been featured in like documentaries and stuff like that. There are quite a few documentaries of this little mouse just
more serious.
Because it looks so like you recognize that motion as being like wolf, majestic wolf howling at the moon, but seeing a little mouse do it, it's great.
I mean, it's probably pretty terrifying for the things that are its prey and capable of feeling fear.
That's true. I guess to us, we're like, oh my gosh, he's so silly. Look at that silly little guy. But I guess if we were a bark scorpion, that would be like horror movie material.
Guess I'll just die.
That'd be like hearing the screech of a dragon. I did want to wrap up Ingenuity with this little line that I found on Animal Diversity Web, because I was trying to see like what their social behavior is like. I saw some kind of conflicting descriptions where some said that they would like travel in packs, but then others said they didn't. So like I couldn't really get a solid like description either way of their any sort of like social dynamics or anything. But I did find this on Animal Diversity Web that I thought was charming. They said Onychomus erinicola, they show very strong aggression towards other members of the same species, and cannibalism has been observed much more frequently than in other rodents. It has been suggested that these mice may live in male-female pairs year-round, although this would seem to shorten the lifespan as one of the pair inevitably kills the other. They really bring that sort of like kill anything in my path mentality even to their own.
Yeah. And rodents in general are, I would say, pretty well known for...
They're so chill with cannibalism. Cannibalism is not that big a deal to rodents.
Yeah.
Anyone who has perhaps owned pet hamsters knows that cannibalism is not as taboo to rodents as it is to humans.
Yeah.
And in this mouse particularly so. They're so cool with it. I was reading about studies where they tried to keep them in captivity, and apparently they didn't make it more than like 72 hours without killing each other. It was on site.
Yeah, yeah.
This is like the most metal mouse I've ever heard of in my life. To wrap things up for the grasshopper mouse for aesthetics, I'm giving them a 9 out of 10. They're very cute. They have this sort of like sandy, like dusty brown color on top and then white on the bottom. It reminds me a lot of like a gerbil. It's like a desert rodent, sort of like sandy brown on top, white on the bottom. They're fluffy. They're really cute. They do have those long scaly mouse tails, so if you don't like those, this is probably not the one for you. But I think they're adorable. They're really cute, and especially when they do their little howl squeak, that's really cute. Like, I know they probably don't want us to think it's cute. They'd probably be really mad if they heard me say that, but it's really cute.
Yeah.
And that is the mighty grasshopper mouse.
Thank you.
Thank you for listening. Let's take a quick break to hear from our friends on the Max Fun Network, and then we'll get to Christian's animal.
Greatest Trek is the podcast for all your modern Star Trek needs. It's funny, informative, and now it's also timely.
That's because every Friday, right after the release of a new episode of Strange New Worlds, Picard, Lower Decks, Discovery, or Prodigy, we bring you a review of that episode.
There's some great new Star Trek coming up, and we're going to cover all of it.
You'll like our show because we're both former video producers, so we bring a lot of insight into the production and filmmaking aspects to these episodes.
And we also have a very refined sense of humor, so we make lots of delightful fart jokes along the way.
So come see why Greatest Trek is one of the most popular television recap podcasts on all of the internet.
Subscribe to Greatest Trek at MaximumFun.org or in the podcast app you're using right now.
Hey there, this is Drea Clark.
This is Alonzo Duralde.
And this is Sparta!
Iffy.
Listen, I got 300 on the brain. We just watched the movie 300 in honor of our 300th episode of Maximum Film.
That's right. And to celebrate this major milestone, we brought back original co-hosts Ricky Carmona and April Wolf.
But just for this one episode, right?
Oh, Iffy, you know we could never replace you.
Some of the voices have changed over the years. Heck, the name of the show has changed too. But through it all, Maximum Film remains
The movie podcast that isn't just a bunch of straight white guys. Deal with it.
Find this and all 300 episodes of Maximum Film anytime on MaximumFun.org.
Okay, my love, it's your turn. What animal do you have for us this week?
This week, I'll be talking about freshwater mussels.
Hear us out.
Yeah, it's really cool and surprising.
Yeah, this is one of those animals that I feel like over the years, I keep hearing little tidbits about them here and there.
Mm-hmm.
And every time it catches me completely off guard. And I'm like, what?
Yeah. This species was submitted by Vi Green.
Thank you, Vi.
Yes, thank you. And they also included very good information and sources, which helped me out greatly.
Oh, that is a great way to make a pitch to us for an animal to talk about, especially with something like the freshwater mussel that upon first glance might not exactly be the most attention-grabbing animal in the world.
Mm-hmm.
So if you can zhuzh up a submission with some teasers, that really does it for us.
The sources of information I'll be using for this include the Center for Biological Diversity, Animal Diversity Web, mass.gov, as in Massachusetts, and a research paper titled Conservation Status of Freshwater Mussels of the United States and Canada.
Interesting.
Yes, by Williams et al., found in the Fisheries Journal in 1992. So first, let's talk about what a mussel is.
Please.
It is a mollusk belonging to the bivalves. So think things like oysters, clams, those kinds of things.
The hamburger style.
Yes.
Things with two shells that hinge together.
Yes, and then kind of close and open there.
They look like a giant mouth. Now, are mussels the things that people eat?
You can.
Okay.
Yeah. Yeah, you can. They're probably less popular than oysters, at least in our part of the world. Or clams or scallops.
Okay.
Yeah.
I'm not a seafood eater, so when it comes to like animals from the sea that people eat,
Sure.
I'm a blank canvas.
I'll talk more about this later, but they are important food sources for animals, though.
Oh, I see.
Yeah.
I feel like mussels are often seen in like shelled middens, like a left behind, like refuse piles and things like that.
Uh-huh. So there's many different kinds of freshwater mussels, hundreds of species of freshwater mussels. They can be found all over the world, basically. I imagine not Antarctica, but the more warm weather animals, it seems, or at least that's where they're most diverse. So like I mentioned, they belong to the class Bivalvia. Other things in there include oysters.
Okay, so they are related to oysters at least. Okay, cool.
But that's a pretty high level of taxonomy.
That's true. In the same way, I suppose that we would be related to like birds.
Well, it's a class. So I'll get right into our first category there of effectiveness. I'm giving a 7 out of 10.
Okay.
So first I want to talk about they are filter feeders.
Okay.
So they filter in water from their surroundings to pull things out to eat. And that includes bacteria, algae, and unfortunately, pollutants in the water.
Oh.
Yeah.
This is a type of feeding that like allows them a pretty high ratio of like intake to energy expenditure, but also they're kind of at the mercy of the water around them.
Yeah. And they can filter water of those things up to 15 gallons a day.
That's a lot.
It is.
For a guy that's not that big.
And they're usually not found just all on their own. There's usually a bunch of them, right?
Right, true. So this is a little powerhouse. It's like a little Brita filter.
So the part I wanted to kind of focus on here has to do with their life cycle. So first of all, they start off as an egg, and then they turn into a larva form, which is referred to as a glochidium, which I believe is the plural form of that word.
Glochidia would be a plural, I think. Would be singular.
Yes.
Would be plural.
There you go. That makes sense.
I took Latin.
I mean, at least one of us. And then they turn into a juvenile, which is basically a very small form of their adult form. And then finally, adult.
Sure. It seems pretty straightforward so far.
Yes. So it's the logistics around it that are interesting.
Oh, really? Oh, yeah. Always a fascinating and wild ride of logistics.
So let's talk about fertilization. They don't move very much, right? So the way they do that is a form of spawning, except only the male is doing that broadcast spawning. So the male is putting out the
genetic material.
Sure, the genetic material. And then the female keeps the eggs inside her and receives that genetic material to fertilize the eggs, right?
So it has to make it back to her, not just to the egg.
Yeah, they're not both spewing their respective parts into the water.
Which a lot of animals do that.
They do.
Yeah.
Like, I think sponges, maybe, corals.
I think corals do that. Yeah. But it has to actually make it to her.
Yes, it does. So then they'll grow until they get around the larva form. This is where it gets interesting. The larva will attach themselves to a host.
A host?
Usually a fish.
Okay, we're hitching a ride. Your Uber has arrived.
And at this form, they're basically microscopic, and they look like itty-bitty tiny versions of adults.
Oh my gosh.
They have the little clamp and everything.
Oh, that's kind of cute.
So they'll attach themselves to a host, basically as a parasite.
Ooh.
To absorb nutrients, and then when they get big enough, they'll fall off as juveniles into the sediment and then grow into adults.
Huh.
That is not always a fish. There is a specific species called the salamander mussel, which, as you might be able to figure out, will attach to mud puppies or giant salamanders.
Oh my gosh. So this little mud puppy is just having the time of his life, doesn't even know he's covered in little mussels.
They're teeny.
I'm having a cool sort of like mental image of like, maybe this could be like a D&D monster or something like that, of like a salamander, like maybe a giant salamander monster that's just covered in like armor that's made out of these little like bivalve shells. It's giving Davy Jones sort of like all the dudes on the ship had like barnacles and stuff growing off of them. That's what I'm thinking of.
I mean, it's not very visible, but they're there.
Yeah. Whether you want them to be or not.
And some species of mussels depend on very specific species of fish. Like they'll only attach to very specific species of fish.
That doesn't seem like a good idea. Because what if none of them swim by?
That's a big problem. Which I'll talk a little bit more about in conservation.
Yeah, for sure. Now, hold on, because you mentioned that this is a little bit of like a parasitic relationship.
Yes.
And they're very, very tiny.
Yes.
Is there some way that they are harming the host that they're on?
I guess theoretically it could get to the point where there's just so many of them. Because in fish, they're often attached in the gills.
Oh, that's not good. That's not where you want them to be.
Yeah, so the problems could arise from what I read, where if they got too many of them, because wherever they're biting basically becomes scar tissue.
Oh.
So if they get too many of these things, it could affect the ability for the fish to take oxygen out of the water.
That's not good.
So this next part, I struggled on whether to include this in effectiveness or ingenuity. I'm including it mostly here in effectiveness.
I feel like there's not a ton going on behaviorally for a bivalve.
So this next part has to do with, okay, how does the parent mussel get its larva onto a fish?
Yeah. They seem pretty high up.
Yeah.
It would be like if we had to like throw our babies onto a blimp that was passing by.
Because most of them are not depending on just kind of tossing it out there and hoping for the best. Some of them have a lure.
No.
Yes.
What?
So specifically the females. So this is modified flesh of their mantle.
Gross.
Well, not, I mean, as someone who has eaten...
Oh, that's true. You're not bothered by it.
Yeah. But this is part of the fleshy bit inside the shell that sticks out.
I see. Their tongue. I would think of it as like a tongue.
It's more like a foot, actually, but
their tongue foot. It's fine.
And they're used to attract those specific fish, because a lot of times they're meant to look like the fish's prey.
Diabolical.
Right? So they could look like crayfish, minnows, snails. And when the fish comes in for a bite, the mussel will expel a cloud of larvae at the fish into the fish's mouth.
No! Oh, gross!
And again, hoping for some clamp-ons on the gills. Because if you're not familiar with the anatomy of a fish, the water that flows into its mouth will flow out of its gills.
Right. There's like a straight shot
Yes.
from mouth out through gills.
Yes. So that's the goal there.
Oh, can you imagine being that fish? Oh, here's my lunch. Ah! Disgusting.
Swarm attack, go.
That's so nasty. It would be like a jacuzzi jet just
Right.
like blasting into their mouth.
So those that can will take the chance to attach themselves to the fish's gills or other parts to start absorbing nutrients.
Horrible.
Now, how did it develop? Because something I haven't mentioned yet, mussels cannot see.
At all.
Right.
So how do they know? How do they know what's going on?
Which seems counterintuitive, but when I think about it, like these kinds of things, having sight doesn't really help you develop these things, right? Because this all comes down to natural selection. Because what is happening here over millions of years is the mussels are developing these lures, and those that better attract fish will then go on to produce more offspring.
So it's not about them looking around, seeing, oh, that fish is
Yeah.
hunting this crayfish, right? Maybe I
Right.
need to make my foot look more like a...
Yeah.
It's not like an intentional choice. It's just that they open their shell and might
Right.
stick out their tongue foot. And if it happens to kind of, you know what? Oh, that's weird. This one has one that kind of looks like
Yeah.
a crayfish. Then that one is going to, a fish is going to approach that one. And then that one is just going to have a better time reproducing and make
Right.
more.
Because these changes aren't something it has like sentient control over.
Right.
So even though it itself cannot see, it has never seen these prey items, or itself for that matter.
It doesn't even know what it looks like.
Yeah. It is through natural selection, it developed these lures that look exceedingly like the prey of the fish that it's trying to target.
That's so interesting because I feel like that just speaks to like the strength of natural selection,
Yes.
that like it can create these really surprising structures with no input whatsoever on the
Yeah.
animal's part.
And I'm talking like markings of the fish,
Oh,
a tail,
wow.
even in one case, like a bit that looks like a gulping mouth.
What?
Yes.
That's so weird.
So yeah,
Wow, that is really interesting.
it is. And not anything I knew about prior to looking at this.
I also agree with putting that in effectiveness because
Yeah.
this seems like something that the mussel has no sort of say in
Right.
whatsoever. That is just the hand they are dealt,
They, like I mentioned, they do.
or the foot they are dealt. Sorry.
Right, exactly. Like I mentioned earlier, they have low mobility. Their lifetime distance is maybe inches to a few feet.
Oh, bless them.
Oh, like I mentioned, they can't see, but they do have ways to sense approaching fish.
I had that briefly in the back of my head, like, well, then how do they know if the fish is coming?
Yeah, it probably has more to do with water movement than anything, or vibrations in the water.
Mechanoreception.
Right. And they can live up to 100 years.
No way.
So it's another one of those low movement, low metabolism,
Oh, that's true.
longevity things.
That's true, because they're not putting out a ton of energy. Like, they're not
Right.
using a ton of energy for their lifestyle, right? So I guess they're operating on a pretty long-term calendar, I suppose.
So moving on to ingenuity, where I'll give a 6 out of 10. So I, again, wanted to mention the use of lures. I thought was pretty smart because, yes, through natural selection, they have those appendages, but also the mussel is able to wiggle that appendage to mimic a fish.
Interesting. Huh. I wonder how that sort of, because that requires some active participation. So I guess I'm wondering, like, that just must be some sort of instinct. Like, oh, this is just what we do. We just wiggle our tongue.
Sure.
We just wiggle our little foot out there, and then a fish comes along.
So, like I mentioned, it's able to sense when a fish is near. So when it does sense a fish is near, that's when it'll, start ramping up the wiggling, etc., to try and get the fish to bite.
Since they can't see, it's really funny to me that from their perspective, they have no idea why this works. I don't know. I just wiggle a whole bunch and then a fish comes over here. I have no idea why. Like, they don't know it's because they look like the fish's prey. Like, from their perspective, they're like, I don't know why this is working. It just works.
Exactly. Some of them will do what I'm calling head clamping, to where when the fish comes in for a bite, the shell will close on the fish's head.
That's so mean.
While it, pumps larvae at this fish.
Oh, gross. This has to be the worst day of this fish's life. This fish is like, you are not going to believe what happened to me.
Some mussels will store their fertilized eggs in gelatinous packets called superconglutinates. And then we'll put that on a several foot long string of mucus.
Oh.
Yeah.
How glamorous.
So basically another like fishing thing there going on.
Oh, so it sounds like they're like using the whole egg packet or the whole larva packet as the lure. Like hoping the fish will come eat it and then get some larva in its gills.
Yeah, yeah.
Oh, that is very bold of them to basically be like, look at all these free babies you can eat, an all-you-can-eat baby buffet. Come eat all these babies in the hopes that some of them will latch onto the gills on the way down.
And here's the smart part of this entire, I guess, overall life cycle logistics, because here's the whole point. So in addition to being able to take nutrients from the fish, there's also a mobility component to this. Because if they didn't do this, where they attached a fish, their only hope of spawning young would be downstream of their current position.
Oh, true.
So if they latch onto the fish, there's a chance that fish will then swim upstream.
Oh.
Yeah.
That makes sense.
And then by the time the juvenile is ready to, slough off or whatever.
It could be higher up than it started.
Yeah.
Huh. That's funny because if they were only relying on the current downstream, that wouldn't last forever.
They would have no hope of going further upstream.
Right. And then eventually, like after a couple generations, you just end up at the
right. If anything, it would recede. Right. So yeah, I thought that was pretty neat and smart.
That is really interesting. That's an interesting way of mooching off of other animals to make up for your own lack of mobility. Yeah. If you can't use your own locomotion, store-bought is fine.
As far as aesthetics go, I'm only giving a 6 out of 10. It's not much to look at, honestly.
Yeah.
But
do they have the cool, like, inner lining of the shell like some oysters do?
They do a little bit. But of course, this kills the mussel. But yeah, they do have that mother of pearl kind of coating on the inside of their shells.
I do like that. Yeah. That's cool.
The outside can have some interesting colors. The one that I was looking at had a little bit of green in there.
Maybe that's from algae, I bet. Yeah. There's probably algae growing on it.
And the ones with lures, of course, they're interesting because they look like other fish. So they can even have colored patterns on them and things, like a stripe, perhaps.
I feel like the yuck factor would not make that work so great for me. If I saw like a mussel shell open and there's some little wiggly dude in there, that's not my intended.
Yeah.
I wouldn't love to look at that.
Mm-hmm. I do want to talk about their conservation a little bit.
Please.
So as of that 1992 paper, of the 297 species native to the U.S. and Canada, 72% were endangered, threatened, or of special concern.
Wow.
And 7% are possible extinct.
Oh, no.
Yeah.
Poor babies.
So they are vulnerable to a number of things, but the biggest is destruction of habitat. So since they're constantly filtering water, they accumulate any pollutants from the water.
Right. Which there's nothing people love more than just dumping every pollutant you can find in there.
Right. So a lot of times they're considered pretty good indicators of overall water health. Because evidently if there's something in the water they don't like, they will close up.
Oh.
Yeah.
Don't like it. No, thank you.
Uh-huh. So that destruction of habitat is important for their own habitat, but also the habitat of the fish that they rely on.
Oh, that's right, because we mentioned like they can't get anywhere without the fish.
Right. And that's important because, like I mentioned, they depend on the fish's mobility. So if that is hampered in any way, that also affects their efforts. So examples of that could be obstructions like man-made dams, that kind of thing. So both in that the fish might not be able to get to them anymore, and then also the fish not being able to get further upstream once they do become parasitized.
Once they're loaded up. Oh, and you also mentioned that like some of them are really highly specialized.
Yes.
So I guess like if the species of fish that they're depending on is suffering from like loss of habitat or like a quality about the water that is like causing that fish species to decline, then the mussel that relies on it is going to then also decline. Yeah. And then also those mussels are then removed from the ecosystem, so they're not doing as much filtering, which is then causing the pollutant to become more concentrated in the water. You're just going to get this sort of snowball like cycling effect.
Yeah, and like I mentioned, they're also very important food sources for things like otters, raccoons, bigger fish.
Humans.
Yeah. So human collection can also affect their numbers. They are also affected by introduced and invasive bivalves. Right?
Oh, no. It's a bivalve versus bivalve smackdown.
So there's that they have to contend with. And one of the reasons they are, or at least were, collected was, at least in the late 80s and early 90s, the shells of U.S. freshwater mussels were valuable to the Japanese cultured pearl industry. That's because they would collect their shells and then grind them into small beads and then use those as the nucleus for pearls in their own mussels and oysters and things to start growing pearls. Because the way pearls are developed, just at a high level, is some sort of irritant finds its way into the, I'll say oyster for example. If like a little irritant, like it could be a grain of sand, finds its way into the oyster, and then it starts surrounding that irritant in what is basically calcium carbonate, which eventually will create a pearl.
It's mechanically not dissimilar from the way that when you get an irritant in your eye produces a lot of tears to try to flush the irritant out.
Or surrounding like a foreign body in like a pus packet.
Yeah. Or a booger in your nose.
Well,
it's a pretty booger is what it is.
So there is a whole farming industry to create those pearls versus just collecting them from wild specimens that grew them as a matter of course. You can find them though.
Yeah.
You'll hear people talk about like, oh, I ordered a bunch of oysters at a restaurant. One of them had a pearl inside.
Yeah.
You know?
Are the farming operations perhaps like offsetting the ecological harm caused by harvesting from the wild? Because I guess if you can just farm them in like a small, maintained area and just only harvest pearls from a cultivated sort of like captive population, that would make you not need to go out and take them from the wild, right? Like I would imagine that would maybe be more ecologically sustainable, like farming them rather than harvesting them from the wild.
I didn't dig too far into that. And there's also the ethical part of it where usually to harvest pearls from these kinds of creatures kills them.
But if you're going to eat them anyway,
that's true. But
you could do both, right?
But a lot of times the demand for that kind of like meat is nowhere near like the amount being produced.
I see. I just would have thought like if we're getting two things from the same animal, you could kind of consolidate that and like use every part of it, right?
You could, but it's all being driven by consumer trends.
That's
right?
true. Aw, man, capitalism strikes again.
So, things you can do, support groups that are trying to limit water pollutants. And of course, not obstructing waterways. Unnecessarily. Unless
you're a beaver. If you're listening to this and you're a beaver, you're fine. Keep doing what you're doing. You're doing great.
There's a trade-off there, I'm sure.
That's only if you are a beaver. If you're not.
And I'm going to check.
Yeah. We've got a lot of listeners out there in the beaver population. It shows up on our demographic analytics. Well, that was great. Thank you so much.
Yeah.
Show some muscle. And thank you, dear listener, for spending this time with us today. We had a great time, and I hope that you did too. And if you liked what you heard, we'd love it if you could leave behind some kind words for us on your podcast app of choice. We really like it when you do that. I promise we do read them all. If you'd like to hang out with us on social media, we're on Facebook, Twitter, Instagram, Discord. I'm on TikTok. I post a lot on there. We're also a little less active on social media than usual because we are in the middle of planning a big move. So, we have a lot on our plates right now, but I promise, we are doing our best to keep connected with y'all. We may have a brief hiatus upcoming. Don't really know the details on it yet, but I promise we'll let you know as they come up. Oh, we'd like to thank Maximum Fun for having us on the network with their other amazing shows, like the ones that you heard promos for earlier. If you want to learn how you can support the network and our show and keep us going, head over to MaximumFun.org. And we'd like to thank Louis Zong for our theme music, which would go super great with a little grasshopper mouse squeak just in there somewhere. Although it's already got that little coquille squeak.
Yeah,
so.
yeah. I'm often reminded of that because the coquille is something that comes up in media pretty often.
There's a little coquille in that pirate show that Finley was watching the other day.
Oh, yeah?
Yeah.
Aww.
So Finley's been, our 2-year-old is in a major pirate phase right now. Last weekend, we took him to a pirate museum that was really cute. And he was watching the show. What is it called? It's a show on Netflix, Santiago, something. You know the show I'm talking about. This little cartoon about a pirate.
Yeah.
I'm sorry, I don't know what it's called, but he has a little pet coquille that sits in his pirate hat and like peeks his head out and does the little squeak sometimes. So there's a little coquille out there. It's so cute. If you want to hear what the coquille sounds like, you're about to in the music, which is playing now. Thanks.
Bye, y'all.
Bye.
MaximumFun.org.
Comedy and culture.
Artist owned. Audience supported.